Good day to you. This is teacher Leland, Alejandro, and we're going to discuss today transformations of quadratic functions. So transformations. So we're going to see the problem set in the other screen right now. So it will be this portion. Okay, so this is the instruction. Use completing the square to write quadratic functions in the vertex form. Y is equal to a times the quantity x minus h squared plus k. Now in this equation, the h and k is actually the vertex, the h and k. So just remember the h and k is actually the vertex. There. That's why this is called the vertex form of the parabola. Okay. Now the parabola is the graph of a quadratic function. Okay. So it can either open upward like that, and the vertex is right here like that. Okay. Or it can open downward like this. Okay. And so the vertex is right there. Now for parabola which opens upward, the vertex represents the minimum. And then for a parabola which opens downward, the vertex is called the maximum point. Okay. All right. So these are some of the concepts we are going to learn from the vertex form. Now let us have the solution for the first problem. So we're asked here to use completing the square, of which we are already finished. Okay. We have done and studied the lesson completing the square. So we're going to apply it here to come up with a vertex form, which is right here. This is the vertex form. Okay, again, the vertex form, we shall write it over here. Y is equal to a times the quantity x minus h squared plus k, where h and k is the vertex. Okay, where h and k, this is actually the vertex of the parabola, the graph of the quadratic function. All right, so for the given, we have here y is equal to 1/3, okay, and we have x squared minus 2x plus 7. Now, we will start factoring the 1/3, okay? We're going to factor the 1/3 out, and we're going to consider the squared and first degree term. Okay, by doing that, we'll be able to make use of 1/3 and then the x squared, and the other term of first degree will be remaining inside the parentheses. So moving a 1/3, okay, it's like this. You have a 1/3 over 1/3, and you have the negative 2x there. It's like this, okay, as if it's like that, because 1/3 over 1/3 is 1. If you move out the 1/3, you have a negative 2 over 1/3, which is a negative 6. Okay, that's a negative 6. So what is left inside is a negative 6x there. Okay, and you'll be able to understand that part if you try to move back inside the parentheses the 1/3. Okay, 1/3 times the x squared, that's a 1/3 x squared. Now multiplying the 1/3 by the negative 6, it returns back to the negative 2. Okay, because that will be a negative 6 over 3. All right, and so that is the correct remaining term inside the parentheses. And so this will be like this, like that. Okay, and after which you're going back to completing the square. You're going to use the 6. Okay, you're going to use the 6, and this 6 will have to be divided by 2. After dividing it by 2, the result is to be squared. And so this is actually 9. Okay, 6 over 2 is 3. 3 squared is 9. So the number we're going to add is 9, and we will subtract at the same time. Now, where is the plus 7? The plus 7 is after the close parenthesis. There. And we're getting close to the answer. Okay. And so we're going to consider now this perfect square trinomial that can now be converted to x minus 3 squared. And you have the 1/3 beside it. The 1/3 will be returned back inside. And so the 1/3 will be multiplied by the x minus 3 squared. Also, it will be multiplied back to the -9. And so that will be a 9 over 3, which is a -3. And the plus 7. And we have the left side of the equation like that. Now, one more step is to combine the -3 and the 7, which gives us a plus 4. And that gives us the final answer. So we have here the vertex form already. This is now 1/3 times x minus 3 squared plus 4. This must be the required vertex form. And the h and k here is actually the 3 and the 4. Okay, the vertex here, if you're asked to get the vertex is the +3, and the k is the 4, the +4. There. So this is the required vertex form. Okay, and you can compare that to the required equation in the instruction. And so we shall verify the answer. We can find it displayed by the computer. It's over here. There. Okay. So y is equal to 1/3 times the quantity x minus 3 squared plus 4. All right. So we're going to continue with the second number. Let me clear the screen. Let's proceed to the second. Okay, here's number 2. All right. The same instruction, use completing the square to write quadratic functions in the vertex form. Okay, so we shall get the given equation, y is equal to -x squared plus 2x minus 11. The technique in completing the square is to take note of the coefficient of the x squared, and whatever that is will be used as the common factor. Okay, and for this equation we have the -1, and that represents the small a. Okay, that represents the small a. So y is equal to -1, and we have the x squared. All right, let this be the parenthesis like that. If you move out a negative from a positive, okay, the remaining sign inside is a negative. So what remains there is a -2x like that. Okay, and you can always verify by multiplying back the -1, and it shall return to the given. Okay, -1 by x squared is -x squared. -1 by the -2x returns to the given plus 2x. And so our factoring is correct, and we shall make use of the -2, this one. We shall make use of that, and we shall divide this by 2, and the result will be squared. Okay, and of course that will be 1 squared, which is just 1. Okay, now this number 1 will be added and subtracted, the process in completing the square. So this will be +1 and -1. And we don't forget the -11 in the original equation, so that will be outside the parentheses. There, it's like that. Okay, and so we shall continue. Right, let me remove the arrow there. This is now the perfect square trinomial. There, and that is the same as x minus 1 squared. There, and let us put a wider parenthesis there. Okay, all right. Okay, the -1 is still there, and y equals. All right. Now, the negative 1 is still right there, and the negative 11 is right there. All right. It's time to multiply back the negative 1. So we're going to multiply back the negative 1. This will now be negative x minus 1 squared. Negative 1 will be multiplied by this negative 1. And so this becomes a positive 1. And we shall now remove all the outer parentheses. And after the plus 1, we have the minus 11 there. And then simplifying one more, we have the final answer, negative x minus 1 squared. This is minus 10. And so this is the required vertex form. Okay, this is the required vertex form. And so if you're asked to identify the vertex, it's HK will have to be represented by the positive 1 and the negative 10. There, that's the vertex. Now, this is the required answer, the equation, okay, which is called the vertex form of the quadratic function. And we can verify that, all right, over here. You can see it below the given, there. That is the vertex form answer. All right, let's continue with the third. Okay, let's continue with the third. Okay, here's the third. Use completing the square to write quadratic function to the vertex form. Here's the given. Remember, the vertex form is y equal to a times x minus h squared plus k. This is the vertex form, okay? Now, the moment you were able to transform the given into something like that, you already have the answer. All right, so this is the solution. This is the given, y negative x squared plus 20x minus 90. All right, now you're going to use the first two terms, okay? You're going to use the first two terms and close it in parentheses, okay? You can try doing this. You can use a larger parenthesis, just enough space for the add and minus, okay, like that. And so we shall determine the common factor, which is the a, okay? The a there is the negative 1, and we shall factor out the negative 1, okay? And so what remains inside will now be a positive x squared. The 20, which it used to be a positive, okay? So that should be a negative and a negative, okay? Now you put out one negative, there is one more negative. Remember, a positive is minus negative, okay? So if you factor out the negative, there is one more negative, okay? So that's why the remaining term there is a negative 20x, okay? Like that. So our factoring is correct. And you can verify that by multiplying back what you placed outside the parenthesis, so the negative 1. If you multiply it back, it shall return to the previous line, okay? And it's clearly correct, okay? All right, now at this point, you're going to use the 20, okay? This 20 here, you're going to use this. This will be divided by 2, and the result, we're going to square, okay? So 20 divided by 2, that's 10. And then when you square 10, it's 100. There. So we're going to make use of the 100. That's what we're going to add, okay? We're going to add this 100, and we're going to subtract this 100. There. Minus 90. There. Why are we adding and subtracting? Because if we add only, we will change the problem, okay? Now, if you add and subtract, we did not add anything. We actually added 0, okay? So it did not change the problem at all. All right, so at this point, this part here is now the perfect square trinomial. And so we have here y is equal to negative 1 times the quantity x minus 10 and squared there, okay? Like that, okay? Now, you should go back to completing the square method if you have forgotten the steps already, okay? All right, so remember, this term here is the square root of x squared. That's why it's x. The 10 came from the 100, okay? The square root of 100, okay? Square root of 100, that's 10, okay? All right, it came from there, okay? All right, and so that's it. Let me just erase those extra writings there. All right, so I can continue with the clean solution. All right, so we now have the, let's put an outer parenthesis, okay, like that. Because we still have the minus 100, like that, okay? And so we have, after that last parenthesis or close parenthesis, we have the minus 90, okay? We can put a fence over there. That's a separate computation. All right, the next line, we put back or multiply back the negative 1. And so this will become negative x minus 10 squared. Okay, the negative 1 will be multiplied by the negative 100, giving you a plus 100. And we still have the minus 90. All right, no more outer parentheses there. Okay, and so this will now be further simplified to get the final equation, the vertex form. This is now the vertex form, x minus 10 squared. This is now plus 190 negative, that's a plus 10, which gives us the final required equation, okay? All right, and so you can verify the answer from here. We can check that out. All right, there. You can see the answer below the given over here. Right there, exactly what we obtained by using the completing the square method. All right, so we shall continue with the number 4. All right, let us clear. All right, let's continue with number 4. Here is number 4. Use completing the square to write quadratic functions in the vertex form. All right, again, the vertex form of a quadratic function is written this way, like that. That is the vertex form, okay? All right, so you will be able to compare the answer, all right? When we already have the answer, okay, you can compare that to that particular equation. All right, so what do we have here? We have the given y is equal to negative 3x squared minus 54x minus 252, okay? All right, so we shall make use of this first two terms, enclose it in parentheses, okay? Enclose it like that, negative 3x squared minus 54x, okay? And then put a space there, like that, okay? And so we will have to factor out the negative 3, okay? Because the x must become x, the x squared should become 1x squared. So we will be putting out or factoring out the negative 3, okay, like that. Now, taking a negative from that negative 54 will leave it positive, okay? And the remaining number inside must be something like 18, okay? 18x, because negative 3 times 18 is negative 54, okay? All right, so the number that we put outside or factored out is the negative 3. And so the remaining terms inside are both positive now, the x squared and the 18x. All right, and so we shall now determine the number to be added and subtracted. We will take that from, of course, the 18, okay? All right, the coefficient of the first degree x. So we have 18 separately computed, okay? So you can put a barricade there. 18 divided by 2, the result of the division by 2 will be squared. So 18 divided by 2 is 9. 9 squared is 81. There. So our number to be added and subtracted is 81. We shall add first and then subtract. And here's the outer parentheses. And then we have the minus 252 there. Okay. To continue, we now have the perfect square trinomial there, which is equivalent to x plus 9, okay, squared. All right, okay. And then we still have the negative 3 in front and the y equals like that. Okay, and we still have that minus 81 beside it. And our parentheses will be there, okay? All right. And so we have that minus 252. And then we shall now distribute the negative 3 back, okay? We will have negative 3 times x plus 9 squared. And then that will be how much? Positive 243, okay? 243 positive, and then minus 252. All right, the next line will just be the difference between 252 and 243. And that will be like, how much is that? Negative 9, okay? 12 minus 3 is 9. So we have a negative 9 here. There. And the rest are the same. So we have y is equal to negative 3 times x plus 9 squared. This is x. And this is the required vertex form. And you can compare this with a format there. Okay. And you can very well see the h and the k. Okay. All right. And so this shall be the required answer. All right. You can verify that at the left side below the original given equation. So you have there negative 3 times the quantity x plus 9 squared minus 9. Okay, that means our solution and answer is correct. Okay, all right. Let's continue with the next. Let's have the next, number 5. Let me just clear it, remove the answer. All right, let's have the number 5. Okay, let's have the number 5. Okay, here is number 5. And the instruction, the same. Use completing the square to write quadratic function in vertex form. Okay, again, the vertex form is y is equal to a times the quantity x minus h squared plus k. All right, so we will start with the given. Y is equal to negative x squared minus 16x minus 72. To start with, we'll be using the first two terms, the squared and the first degree x. Okay, we put it in a parenthesis, negative x squared, negative 16x, and then like that, and then we still have the minus 72. So it's just grouping, okay? Just grouping, okay? We did not change the problem. All right, we shall now factor out the negative in front of the x squared. So we have a negative 1 times x squared. We have a plus 16x. Okay, so this is a negative there. And so we shall use the 16. We divide the 16 by 2. And after dividing it by 2, we're going to square it. So 16 over 2 is 8. 8 squared is 64. There. So we're going to use the 64 to be added and subtracted. So plus 64 minus 64, close parenthesis, minus 72. Okay, we now have our perfect square trinomial, which is equivalent to Square root of x squared is x. Square root of 64 is 8. And then the sign will be the sign of the 16. The 16 has a plus sign, so this will be plus. That's how to do the completing the square. All right, the rest will now be rewrite. Okay, and then this will now be, of course, the negative 64 is still there. Okay, and this parenthesis will have another one over there. And then this is followed by the minus 72. Okay. All right, so we distribute the negative one. We will have negative x plus h squared. Negative 1 times the negative 64, that becomes plus 64 minus 72. And then one more step, okay, will just be the difference between 72 and 64. And that will be a negative 8. So that'll be a negative 8 there. All right, and so the rest will be copied there. And so this is the required vertex form. Okay, verify the answer. Okay, try to see it below the given. There. Okay, so exactly what we obtain. All right, I hope you're getting the method to get the vertex form. All right, let's continue with the 6. Here's number 6. Okay, here's number 6. All right, we have here some fractions. All right, the terms have divided by 3, all of them. 1/3, 1/3, and then 1/3. All right, so again, we will be trying to express the equation into something like this. That's what you call the vertex form, okay? Vertex form. All right, and so we shall begin with the given. We have here y is equal to 1/3 x squared plus 10 over 3x plus 43 over 3. Okay, so we shall try to make use of the first two terms. And so we have here 1/3. Let's put out the 1/3. Okay, so we have here 1/3. Okay, take note, we're making use of the first two terms, the squared and the first degree x. So putting out the 1/3, we shall have inside the grouping symbol x squared. And putting out the 1/3 from 10 over 3, then we still have the 10, okay? So that will be plus 10x. And so this will now be parentheses plus 43 over 3. So we did not involve the 43 over 3 in the factoring, okay? That's why it's isolated, all right? So remember, we're just only using the first two at the left side of the trinomial, okay? Only this. All right, and so we shall continue now with the number to be added and subtracted. We're going to use the 10 now. Okay, we're going to use the 10, the coefficient of the first degree x. So 10 over 2. After dividing by 2, we're going to square it. So this is 10 over 2 is 5. So we have 5 squared. That should be 25. Our number to be added and subtracted is 25. So we shall add here 25 and subtract the same 25 there. And we now have the perfect square trinomial, which can be written in one group, okay? So one parenthesis, and it will have to be squared. So remember this outer parenthesis, that's the one, okay? Now these 3 terms, this is equivalent to another group, squared, like that. And this is equal to x plus 5 there. And so the minus 25 is still there, and the 1/3 is over here, and the equals and the y. And we still have the plus 43 over 3. All right, the next line will now be distributing back the 1/3. Okay, distribute back the 1/3. So we will have here 1/3 times x plus 5 squared, and that will be a negative 25 over 3. Negative 25 over 3 plus 43 over 3. Now, remember, we have both fractions with the same denominator 3. We can get the difference between 43 and 25. And that looks like, how much is that? 18? It's a positive 18 over 3, okay? It's a positive 18 over 3, there, okay? That means 43 positive and 25 negative is the same as 43 minus 25. That's why it's a positive. And that will become 13 minus 5, 8, and then the 4 became 3. 3 minus 2 is 1. So we have the 18 and still divided by 3. The rest of the left side will just be rewritten. So this will now be y is equal to 1/3 x plus 5 squared. There. And we can still simplify. 18 over 3 is a whole number 6. So our final answer will be y is equal to 1/3 times the quantity x plus 5 squared plus 6. There. All right, that should be it. All right, that is our vertex form, and it resembles the format on top, okay? Take note, it resembles the format on top, there, okay? If you're going to examine, the A is the 1/3. The H is negative 5, because that plus 5 there, that means minus 5, okay? So if you're asked, what should be our HK, okay? Your H there, looking at the formula, there's a minus in the formula, and in our answer, it's a plus. So that means you can rewrite that. To identify the correct sign, you can rewrite that x minus negative 5 squared plus 6. And you can very well see your H is a negative 5 there. Your H is a negative 5, and your K is a 6. All right. Okay. So you were able to get the correct sign of the 5. All right. Because the formula is a minus h. All right. And so this is the answer at the center. Y is equal to 1/3 times the quantity x plus 5 squared plus 6. And we can verify that. Let us see it over there. All right. There you are. Okay. Same as what we obtained. Okay. The same as what we obtained. Let's continue with the 7th. All right, let me clear the screen and remove the answer from 6, because if we jump to number 7, sometimes it displays the answer in number 7. Okay, so let me just erase first. All right, there. All right, let's continue with next. All right, we have a slightly different format here. Okay, but still use completing the square to write quadratic functions in the vertex form. Okay, let us see if it requires completing the square. I think it's more on just simplifying it, okay? All right. Since you already have that x plus 6 squared, that takes care of the x minus h squared part. So let's have the given first for our solution. So for our solution, okay, we have here a negative 1/2 times the quantity y minus 6 is equal to x plus 6 squared. Okay, so you can see a negative 1/2 at the left side of the equation. If you can only make that y, okay, letter y right away, okay, like that, then we're done, okay? Because the format is y is equal to something. But we have something else there. There's a negative 1/2 and a minus 6. So we will do it slowly. First is to multiply both sides of the equation by a negative 2, okay? So we will have to make this, all right, multiply it by negative 2, okay, times, you still have that negative 1/2 y minus 6. There. All right. We're done multiplying the left side by a negative 2. Okay. Now we shall also do the same at the right side. So negative 2 times x plus 6 squared. There. All right. Notice the negative 2 and the negative 1/2 at the left side. That will produce a positive 1. Okay. That cancels out. Okay. So the left side will just become y minus 6. The right side is now negative 2 times x plus 6 squared. All right. So one more step. We only need to transfer the negative 6 by way of addition. So we add 6 here and we add 6 there. And that's it. The left side is now just y, and the right side looks like the vertex form. And we have x plus 6 squared plus 6. All right, this must be the answer. All right, let's find out. And try to see the answer below the given. There, okay? All right, as displayed by the computer's database. All right, the answer is correct, okay? And so we're done with number 7, okay? All right. It looks like we did not do any completing the square there, but we got the answer just the same. All right, let's continue with number 8. Let me clear the screen and continue with number 8. All right, here's number 8. It's slightly different from the usual polynomial type, okay? All right, so let's see how we can transform it to the required vertex form. The vertex form is always like this. There's the vertex form. Now, our given is a minus y plus 7 is equal to x plus 4 squared. Okay, so first we shall multiply both sides by a negative 1. Okay, so negative 1 times, all right, what do we have at the left? It's negative something like that. Okay, and so we multiplied by negative 1 so that that negative at the left side will become positive. Now, if you do that at the left, you will have to do it at the right. So that means negative 1 times x plus 4 squared. Okay, let us simplify now the left side. Negative 1 times that negative over there, that will become positive y plus 7. And we have the right side negative x plus 4 squared. Okay, and it looks like the vertex form already. We only need to move the 7 by way of subtraction. So that's a plus 7. So to make it 0, we shall subtract 7. We shall subtract 7 there. And so final answer is right here now. It's negative of x plus 4 squared minus 7. And so this is it. This must be the answer. All right. Let me remove my check. Okay. We still have to see that. All right. Let us over here. There. Okay. All right. Y is equal to negative x plus 4 squared minus 7. Now I check it. All right. There. Okay. So we're now going to have number 9. All right. Let's get number 9. Here is number 9. Okay. Use completing the square to write quadratic functions in the vertex form. Okay, let us see what we need to do here. All right. We have 34 plus 3x squared equals negative 18x minus y. All right. We have the y at the right side. The usual position of the y must be at the left side. Okay. So we shall move that y to the left side. Okay. All right. And so let's get the given first. The given is 34 plus 3x squared equals negative 18x minus y. All right. Now, if we do some transposition, all right, transposition, that means we will shift terms from left to right and terms from right to left, okay? And changing the signs every time we do that, okay? All right, so let us move the y, okay? Let us move the y to the other side, okay? So if we shall start with the word transposition, okay? Transposition, there, okay? So let's put the equal sign. Okay, there's the equal sign. If you put the negative y to the other side, it becomes a positive y. There, okay? All right. Now, you can see the 18x is a negative where it is stationed. All right, that's a negative 18x at the right side. So we will have it just right there. And no change in sign because it's still there at the right side. Okay. All right. What we're going to do is the 3x squared at the left side, we will move that to the right. Okay. If you do that, that positive 3x squared becomes a negative 3x squared there. All right. Remember, if you do transposition, the sign will change. Okay. If you move the term from left to right or vice versa. All right. So from left, the 3x squared becomes negative going to the right. All right. What else? The 34. Okay. We will move that to the right. And 34 becomes negative. There. Okay. And that's it. And it looks familiar now. Okay. And now we attempt to do the completing the square. All right. Completing the square now. All right. We shall now use these first two. Okay. Factor out the negative 3. So we have a negative 3 out. What remains inside the grouping symbol will be x squared. Okay. Moving a negative from the 18, we will still have a 6. Okay. 6x there. And of course, the sign of 6 will be positive there. Okay. You can always verify. All right. Just move back the negative 3. It should return to the previous line. Okay. That's a negative 3x squared, negative 18x. All right. And so we shall now put a close parenthesis followed by the minus 34. Remember, the negative 34, we did not include that in the process. So it will now be just the first two, and we use the factoring. Now, we shall make use of the add and subtract, and that number will come from the 6. You divide 6 by 2, and then after dividing by 2, you square it, and 6 by 2 is 3. You square it, that's 9. Okay, all right. 9 will now be our number, plus 9 and minus 9. There. Okay, we now have our perfect square trinomial. Okay, we have the outer parentheses, like that. We have the minus 34. We have the negative 3. We have the equals and the y. All right, what happens to the trinomial? That will be reduced to a grouping symbol, squared. Okay, the first term is the x. The other term is the square root of 9, and that's 3. The sign in between them is the sign of the middle term 6x. That will be plus. There. Okay, after which we still have that minus 9 over there. Okay, at this point, time to multiply back the negative 3. So this is a negative 3 times the quantity x plus 3 squared. Okay, the next multiply is the negative 3 by the negative 9, making it a plus 27, and no more outer parentheses at this point. All right, and we still have the minus 34. All right, so the next step is the final answer. This is y equal to negative 3 times the quantity x plus 3 squared. It's now the combination of plus 27 and minus 34. The 34 is larger, so this will be a minus, okay? And a difference of 7. And that's it. It's the required vertex form. Let us verify the answer. Try to look below the given for the answer. Okay. Is it the same? Yes, it is. All right, so that's it. This must be the right vertex form. We shall continue with number 10. All right, let's continue with 10. All right. Number 10. All right, here's number 10. Use completing the square to write quadratic functions in the vertex form. All right, so how do you approach the problem? Make it a polynomial by way of multiplication. All right, so we will have to transform it such that it should appear this way later. This is the objective, okay? All right, it should look like that because that's the vertex form, okay? Now, the given is it doesn't look like the vertex form yet. So we shall start there. We have the 2 and then x minus 10, okay? And then you have x plus 2. All right, multiply term by term using the two binomials, okay? This times this, all right? So we have y is equal to 2 times, what do we have there? X and x squared. X and the 2 is 2x. So we will have plus 2x. So we're done multiplying the x by the x plus 2. It's time to multiply the negative 10 by the x plus 2. So let us remove the arcs. We're doing now like this. Negative 10 times the x. Afterwards, negative 10 times the 2. All right, what do we have in negative 10 by x? It's negative 10x. And the next one is negative 10 by 2 is a negative 20. And this will be enclosed. All right. And then we shall simplify a little bit. Y is equal to 2 times x squared. 2x and minus 10x results to negative 8x. And followed by the minus 20. There. Okay. Now what do we have? All right. It seems like we don't have to multiply back the 2 yet. All right. Because it's already 1 in front of the x squared. Okay, you can see that x squared is a 1. So there's no need for factoring. All we need to do is determine the number to be added and subtracted. Okay, that will come from the 8. So we start with the 8. Regardless of the sign, you divide it by 2. After dividing by 2, we will have to square it. 8 divided by 2 is 4. 4 squared, it's 16. Okay, our number is 16. Okay, we will have to insert that after the 8x. So this will now be 2 times x squared minus 8x. Okay, minus 8x, add 16. All right, subtract 16. And then followed by the minus 20. Like that. All right. Take note, they are all inside the parentheses, including the minus 20, okay? All right. Okay, now we shall make use of the perfect square trinomial there. And this will now be in one group, okay? All right, one group. So let's put the outer parentheses there. Okay. Let's have that trinomial converted. That is equal to a binomial squared there. And that's equal to x. Square root of 16, that's 4. Sign in between them, sign of the 8x. All right. There. All right. How about the negative 16 and negative 20? All right, that's a negative 36. Negative 36 there. All right, negative 36. All right. Now we distribute back the 2, okay? We're going to distribute back the 2. So this will now be 2 times x minus 4 squared. And then multiply the 2 and 36. That looks like a minus 72 there. Okay, that's it. All right. So this will now be the vertex form. Okay. This will now be the vertex form. So that's it. All right. Let us check the answer. All right. There. All right. So 2 times x minus 4 squared minus 72. All right. So that's it over there. So this must be the right vertex form. So what is our h there? The h is for, the k is a negative 72, okay? It's a negative 72. All right, so let's continue with the next. Let's continue with number 11. All right, let's clear the screen. All right, and number 11 now. Here is number 11. Use completing the square to write quadratic functions in the vertex form. Okay, let us see the given. Here's the given. They are all in one side, okay? This is the given. They are all in one side. Negative 19x squared minus 76x plus y minus 68 equals 0. Okay, nothing is at the right side. Okay, and we are after a form y equal to something at the right side. All right, so what we need to do here first is let us retain the y just right there, okay? The other 3 moves to the other side by means of transposition. There, all right? We did one transposition a while ago. All right, we will do it again, all right? Let's start with the equal sign. Let's put it over here. All right, okay. Let us start with the negative 19x squared, which is at the left side. All right. If we move that to the other side, to the right, that becomes positive 19. Also, at the left side of the equation, we have the negative 76x. So if you move that to the other side, that becomes plus 76x. What else? We have the number negative 68 at the left side also. We shall move to the right side. That should become plus 68. All right. The y, it stays there. All right. So there won't be any change in sign there. Well, the 0, don't mind the 0. It's a 0. All right. Okay. So that's it. We already have the y equal to something. All we need to do is do the completing the square. All right. And we shall begin in these first 2 terms. Our factoring starts with a 19. Okay. 19 goes out of the group. And this will now be 19 times x squared. All right. What is 76? 76 is 4 times 19, right? 76 is 4 times 19. 36, carry 3. Yeah, I'm doing a multiplication there. 4 times 9, 36, carry 3. 4 times 1, 4. 4 plus 3, 76. Okay. So if we move out the 19, we still have a 4. Okay. We still have a 4x there. Okay. Now we are not going to include the 68. So it will be outside the grouping symbol. and we put a fence there. All right, like that. Okay, now we are going to make use of the 4. Let me remove the multiplication there. And let me put back the fence. All right, this time we will use the 4 in the 4x. So the 4 will be, all right, just like all the other numbers, we will divide by 2. And the result of dividing by 2, we will square. 4 over 2 is 2. 2 squared. 2 squared is 4. All right, so our number to be added and subtracted is 4. So plus 4 here and minus 4 here. And so now we have the perfect square trinomial. Okay, and we can convert that. This is now x, and 2. And the sign of the 4x is plus. All right, we still have the minus 4 right there, and the 19 outside, and equals y there. Okay, we're closing to the answer. All right, so this will now be y. Let's multiply the 19 back. Okay, so this will now be 19 times x plus 2 squared. We now have 19 times the negative 4, so it's a negative 76. Okay, so that's yes, plus 68. This is now 19 times x plus 2 squared. All right, it's now the combination of 68 positive and the 76 negative. 76 is larger, so this will be a result negative there. And that will be 16 minus 8, that's a negative 8. And so this gives us the vertex form. Okay, that's the vertex form. And we shall verify that. Check the answer below the given. There, okay. All right. And we have here exactly what we have at the bottom. Y is equal to 19 times x plus 2 squared minus 8. This must be the right one. Okay. Number 12 now. Let's continue with number 12. Let me clear the screen. Number 12. All right. Here is number 12. Y is equal to 3 times the quantity x plus 10 times the quantity x plus 3. Okay. So all we need to do if you have something like this is get the product first. Y is equal to 3x plus 10 x plus 3. Okay, you're after the vertex form. Okay, and the vertex form is y is equal to a times x minus h squared plus k. That's the vertex form. Okay, all right. So before you can do the completing the square, we shall multiply the two binomials first. So x times x and then x times 3. So this will be x times x is x squared, and then followed by x times 3. Both positive gives plus 3x. And so we are done distributing the x. We shall now continue with the 10 multiplied by x multiplied by 3. So we're going to have 10 times x is plus 10x, and then followed by 10 times 3, which is 30, plus 30. Now remember, the number 3 in the given problem will have to be multiplied by this product. So that will be all in one grouping symbol. Okay, so now we will have to combine something for simplification. We can combine this. Okay, and the rest will be copied. So y is equal to 3 times x squared, and then you have the plus 30. Okay, what happens to the 3x and 10x? You will add the 3x and the 10x. They're both plus. So we will have plus 13 x. There. Okay. Now we can do the completing the square now. Okay. Remember, the x squared is now with a positive 1 coefficient. So we can just use the 13. Okay. Use the 13 in front of the first degree. Divide it by 2. The result of division by 2 is squared. Okay, so 13 times 13 is 169. 2 times 2 is 4. There. And that will be our number. Okay, so this will now be 3 times x squared. Okay, plus 13x plus 169 over 4 minus 169 over 4. We still have the plus 30 inside, like that. Okay, after which we now have this trinomial that can be reduced to a binomial squared. Okay, so this will still be y equals 3 times, let's put the original parenthesis. The trinomial is now equal to binomial squared. There. Okay, and so this is now x. The 169 over 4, you will get the square root of that. That returns to 13 over 2. And then the sign in between them is the sign of the 13x. There. And so we still have now the minus 169 over 4. All right, so this is plus 30. We will have to combine the 30 and the 169 over 4. But the 30 is a whole number. The 169 over 4 is a fraction. We shall make the 30 a fraction. All right, so we shall multiply it by 4 over 4. Okay, so that it will have a denominator 4. There. Okay, that's a multiplication. The dot. All right, that's a multiplication. So 30 times 4, that will become 120 over 4. Okay. All right. So let us rewrite one more. Y is equal to 3 times the outer parenthesis. And then we have that binomial inside, x plus 13 over 2 squared. Okay. We now have minus 169 over 4. Now the 30 is now 120 over 4. There. And close parentheses there. Okay. Now we can combine them. They have the same denominator. So it will just be a difference between 169 and 120. And that will be about 49. Okay. So it's a negative 49 over 4. Okay. 9 minus 0, that's 9, 16, or 6 minus 2, that should be 4. 1 minus 1 is 0. So that should be a 49 over 4 negative, okay? All right, and so we continue in the other side. Let us erase some parts at the left side. Let me remove the format. All right, let's continue here. Let's continue over there, okay? All right, and so this will now be y equals 3 times, okay, we still have that x plus 13 over 2 squared, all right? And now we have, how much is that? Negative 49 over 4. Negative 49 over 4. Still inside the parentheses. Now it's time to distribute the 3, okay, back inside. And so we're going to have here the product of 49 and 3, okay? That will be 49 times 3, 27, carry 2, 12, 14, 147, okay? Yes, 147 over 4. So this will now be y is equal to 3 times x plus 13 over 2 squared. Now this is negative 147 over 4. And this is our vertex form. Okay. All right. So that'll be 49 times 327, 2. Yes, it's a negative 147. All right. So that's our answer at the left side. All right. Enclosed. So let us verify the answer. All right. Let us see. Okay. And that looks like identical with ours. So that's 3 times x plus 13 over 2 squared minus 147 over 4. As displayed by the computer, that's the correct answer there. And so is ours. All right, there. So that's a minus 147 over 4. That's the k. All right. Our h there is negative 13 over 2. You can figure that out later. All right. So what requirement we have here is just the equation. All right. So that's finished with number 12. So I hope you are getting the method. Okay. Let's continue with 13. Let me clear the screen. And then the answer. Let's continue with 13. All right, here's number 13. Okay, we have something different here now. Write the required equation for the following. Let's read the problem. Given the function y is equal to 5x squared, write the equation in vertex form when it is translated 3 units right and 2 units up. Okay, so if you want this curve or graph of this equation, all right, this is something that looks like this. Okay, this is 5x squared. So the vertex must be at the origin. It's like that. Okay. All right, this is the origin. That's the origin, 0, 0. This is the x, and this is the y, like that. Okay, that's the y equals to 5x squared. Now, write the equation in vertex form when it is translated 3 units to the right. All right. And 2 units up. Okay. So this is it. If you start with the given 5x squared, to move this up, we add 2. Like that. This is moving up. All right. Now, to translate that 3 units to the right, it will be like this. 5, and then you have x squared plus 2. Okay. That x, we will have to move to the right by 3. That means we will subtract a positive number. Okay. So translated 3 units to the right, that means minus a positive 3. There. Okay. And the curve will be moving. The curve will be moving to the right and then lifted up by 2 units. So it will be like this. There. Okay. Moving to the right by 3 and moving up by 2. It's like that. Okay. All right. And so it will be at the vertex 3, 2. Okay. So the vertex here is 3, 2. So our answer here is this. Okay. This is our answer. This is 3 to the right and 2 up. All right. So let us verify the answer. I think there's the answer here. There. 5 times the quantity x minus 3 squared plus 2. There. All right, so that goes to our number 13. Let's continue with the next, number 14. Let me clear the screen. and continue with 14. All right, here's number 14. Write the required equation for the following. Given the function y is equal to 7x squared, write the equation in vertex form when it is translated 4 units left and 3 units down. Okay. All right. So again, the graph here, will have something like this. Okay. Let this be our x and y. All right. That y is equal to 7x squared will be a parabola that opens upward like that with a vertex at 0, 0. Okay. That is actually y equal to 7x squared. Okay. All right. Now, write the equation in vertex form when it is translated 4 units to the left, 4 units to the left, and 3 units down. Okay. So to put it down, this is 7x squared minus 3. And all y values will be 3 less. Okay, that is why it goes down. The graph will go down by 3 units. Now, translated 4 units left, we're going to subtract a negative 4. Okay, this is down. Okay, this is down. All right, that minus 3. All right, now to translate that to the left, okay, we have something like 7 times, there's the x, this is still squared, there's that minus 3. We will have to subtract a negative, okay, because it's going to the left, okay. So we're going to subtract, okay. The number 13, we're supposed to move to the right, okay. Now this one is translation of 4 units to the left. So we're going to subtract a negative there, okay. And minus a negative, that is plus. So this will be finally y is equal to 7 times the quantity x plus 4 squared minus 3. There. That should be it. Okay. All right. It is now down by 3 and translated to the left by 4. Okay. So minus negative, that will become plus. And so the appearance of this curve, it will now be down by 3 and somewhere here, okay, like that. Down by 3 and to the left by 4, okay, to the left by 4. So it's the vertex is at negative 4, negative 3. This vertex, that's at negative 4, negative 3. There. That's why this is the vertex form, okay. That's a minus negative 4 and then plus a negative 3. Okay, remember the vertex form, it's y is equal to a times x minus h squared plus k. So this means plus a negative 3. That's why our k is a negative 3. Okay, and our h is a negative 4. There. Because the minus is part of the formula. All right, so let us check and verify the answer. All right, over here, there is the answer. Y is equal to 7 times the quantity x plus 4 squared minus 3. Here's the answer. There, okay? All right, so that will be for number 14. Okay, so let's continue with the next. Let's have number 15. Let us clear the screen. Continue with the next. All right, here's the next. write the required equation for the following. Write the required equation for the following. Given the function y is equal to 8x squared plus 3, write the equation in vertex form when it is translated 5 units left and 2 units down. Okay, 2 units down. All right, and so the given here, all right, we can see the given, it's y is equal to 8x squared plus 3. Okay, that's the original equation. Now, write the equation in vertex form when it is translated 5 units left and 2 units down. So 2 units down means you subtract 2. Okay, 2 units down. So this will be like this, 8x squared plus 3. If you subtract 2, okay, that means 2 units down. 2 units down. There. Okay, if you subtract 2. So this will become 8 is equal to 8x squared plus 1. There. Okay, all right, let's continue with the red. All right, this is already down by 2 units. Now we still have to translate it 5 units to the left. Okay, if it's going left, it will be minus negative 5. Okay, so we will put that in the x. So this will now be like that, and the x is there. Okay, it used to be x plus 0 squared. That's why it's x squared. Now we will have to move the graph 5 units left. So we will have to subtract a negative number. Okay, subtract a negative 5. There. And so this will now be y is equal to 8 times x plus 5 squared plus 1. Okay, and that should be the answer. Okay, 5 units to the left and 2 units down. All right, and so we shall see the answer over here. Okay, all right, so there you can see the answer below the given statements. Y is equal to 8 times the quantity x plus 5 squared plus 1. All right, so that goes to our number 15. Okay, so where is the vertex? The vertex is at negative 5, positive 1. That's the vertex. So if you're going to draw this, all right, a little drawing will do. Imagine this is your x and y axis. All right, it used to be like 8x squared plus 3. So the vertex is not at 0, 0. It's at 0, 3. Okay, so the graph is right here. There. That's the given. Now, after the transformation, okay, it will be at negative 5, 1. Okay, it will be at negative 5, 1. So it will be somewhere here. The graph will be at negative 5, 1. So that should be like that. Okay, negative 5 and up by 1. So take note, it went down by 2. All right, so the point here, okay, that point is negative 5, 1. Okay, this point here, that's negative 5, 1. How about the other? How about this point here? How about that point? This point, that point is 0, 3. Okay, there. So the blue curve That is represented by this. Okay, there. And so that's the answer. Okay, that's the answer. And you can see the answer over here. Okay, all right. Okay, so we shall continue with the next. Let's have number 16. Okay, here's number 16. Write the required equation for the following. Describe the transformation. Okay, describe. This is only describe. Describe the transformation from the graph y is equal to 4 times x plus 6 squared plus 3 to the graph of y is equal to 4 times x minus 5 squared plus 1. All you need to do is compare the vertex. Okay? We shall just compare the vertex. It's from, all right, it's from y is equal to 4 times x plus 6 squared plus 3. Okay? And you can rewrite this using the vertex form. The vertex form is 8 times x minus h squared plus k. All right. We can identify the actual sign of the h if we use the minus in the formula. So this is y is equal to 4 times x minus 6 squared, all right, minus 6 squared plus 3. That means the vertex here, the vertex hk, all right, is actually negative 6, 3. There. Now, the second equation is, all right, to the graph of, all right, here is the second. Y is equal to 4 times x minus 5 squared plus 1. Okay, and the hk here, it's a positive 5 for the h and a positive 1 for the k. All right, so the y movement, the movement of the vertices, all right, the k is from 3 to 1. Okay, that means 2 units down. Okay, so we have 2 units down. Also, let's examine the h. Let's examine the h. All right, from negative 6, that's to the left of the origin. 6 units to the left of the origin. Okay, that's the location of the vertex. And afterwards, the h now is plus 5. Okay, so that means 5 units to the right of the origin. So it's from negative 6 to positive 5. That should be 11 units to the right. Okay, 11 units to the right. 11 units right. Okay, all right. So from negative 6, 3, that's located at the second quadrant. It moved to the first quadrant at 5, 1. So the distance from negative 6 to positive 5, that's 11. Okay, so remember, it's from this vertex going here. All right, describe the transformation from the graph to the graph. All right, and so that means it's 11 units right and 2 units down. Okay, that should be the answer. That's the description. All right, okay, so describe the transformation from the graph to the graph. All right, and so this will now be the answer. Okay, all right, translated 11 units right and 2 units down. Okay, you can read it here. All right, there. Okay, translated 11 units right and 2 units down. Exactly what we stated right here. All right, there. Okay, so that's it for number 16. And That's for our number 16. And I think this is the last number. So we shall be discussing more later. So this will be all for now. See you later. And I hope you were able to learn from our 16 examples. Okay, so see you later.